Okay, moving on to multiplying decimals. Now, in the Edpuzzle video, the Math Antics guy talked about how multiplying decimals is just like multiplying regular numbers. You just have decimal points. And so really the decimal points, it doesn't change the numbers that we're going to end up calculating. It just changes the worth of the number. So the first problem that I'm going to start with is this, and it's pretty simple. And it's 12, so 12 whole times 5/10. Okay. And I want to look at this for a second because I want to talk to you about what this problem is telling us. So it's saying that I have 12 halves, or I could say I have half. If I wrote it like this, I have half of 12. Okay. So if I had 12 halves of pizza, how many whole pizzas would I have? Or if I flipped it around, yeah, I would have 6 whole pizzas. Or if I flipped it around and if I said I had half of 12, half of 12 is 6, right? So all that is happening here, and you can also think about this as money. What if I went like that? If you had 12 groups of 50 cents, you would have 6 whole dollars, okay? So really all we're doing when we are multiplying decimals, and he said this in the video, is that you're basically ignoring the decimal point. So we're kind of ignoring the decimal point, okay? So pretending that it's not there, and we're going to go ahead and multiply. 12 times 5 is what? 60. Okay. So 12 times 5 is 60. So when I put the decimal point back in there, 12 times a half, my decimal point, and he counted how many places were after the decimal point. So I've got one spot after my decimal point, or one place after my decimal point here. So in my answer, I'm going to need to move that back one space. And so my decimal point would go right there in between the 6 and the 0, which would essentially just mean 6 whole. Okay. That one was pretty easy. Let's talk about another type. And this is when we multiply a decimal times a decimal. So I'm going to say 5/10 times, we'll say 7/10. Okay. 5/10 times 7/10. Okay. Now, this is like saying half of 7/10. Now, if I said half of 70 cents, how much money would you have? Half of 70 cents. You'd have 35 cents. Okay. If I had a pile of 70 cents and I took half of that, I would have 35 cents. Okay. Here's how this works. So I'm going to get rid of the stuff that I added. All right. So I'm going to go back to 5/10 times 7/10. I'm going to ignore those decimal points, and I'm going to treat this problem as if it were 5 times 7, right? What is 5 times 7? 5 times 7, 35. Okay. Now, I know that I'm not taking 5 whole times 7 whole, or I do not have 5 groups of 7. I have a half of a group of 7/10. So if I count how many spots I have after my decimal points, there's 1 and 2. Okay. I have 2 places after my decimal points. So that means I need to move the decimal point in my answer back to the left 2 spots. And so it ends up being right there, and we can put a 0 right there. Okay, so 5/10 times 7/10 is 35 hundredths. Okay, and again, if I explained it to you in the words of half, oh my gosh, half of 7/10, that's going to be 35 hundredths. Okay, or half of 70 cents is 35 cents. So basically, when you're multiplying decimals, you're multiplying like normal and putting the decimal point in your answer. Okay, let's do another example of that. Let's do 1 and 5/10 times 3/10. Okay. And I'm going to rewrite this vertically. Okay. I'm going to ignore those decimal points and I'm going to act like this problem is 15 times 3. Okay. And if you need to write it like this, you can. So I've got 15 times 3. So I could say, if you know 15 times 3, that's great. But if you don't, you can work it out like this. So 3 times 5 is 15. I'm going to carry my 1 over here. 3 times 1 is 3, plus 1 more is 4. Okay, so 15 times 3 is 45, but that's not what my original problem is. It's 1 and 5/10 times 3/10. So the only difference is that I have decimal points. My digits are all the same. Okay, so I count how many places I have after my decimal point. So there's 1 here, there's 1 here, for a total of 2 places. And so in my answer, I just slide it back to the left 2 places. And so my answer would be 0 and 45 hundredths. Okay. And I want to talk about estimating these kinds of things. So a lot of the times students will say, well, I'm not really sure why my answer is smaller than what I started with. Usually, when you multiply 2 numbers together, your answer is bigger. So, why are we getting a smaller answer? Because we're not multiplying by something that's equivalent to 1 whole. Okay, so let me scroll down here again. If I took 1 and a half and multiplied it by 1, I would end up with 1 and a half again, correct? Yeah. But if I'm taking 1 and a half times something that's less than 1, like this guy, my answer is going to be less than 1 and a half. Okay. I am taking a part of a part, if you will. So again, this answer would have been 45 hundredths. Okay. Now, sometimes you will see on a test or a quiz something like this, where you have, let's say I've got 2.3 or 2 and 3/10. Oh, that's a sloppy 3. 2 and 3/10 times, we'll say 6 and 12 hundredths. Okay. 2 and 3/10 times 6 and 12 hundredths. Okay. And what you would normally do for this is you would set this up like a normal multiplication problem. I would put the 6 and 12 hundredths on the top. just so I could set up my multiplication problem like this. Okay, now, what is not lined up in this multiplication problem? The decimals, okay? The decimals do not have to be lined up when you are multiplying, because what are we doing with our decimals at the beginning? We are just pretending that they what? Yeah, we're pretending that they disappear, okay? So we want to set up our problem like we would if we were multiplying these two numbers together as if they were whole numbers. So we can kind of ignore those decimal points and solve the problem like this, okay? Which you're probably a little bit rusty on this skill, which we'll have to work on. But I want to talk to you about estimating first, okay? And this is why estimating is very, very important. I highlighted those two whole numbers, correct? Okay. And if I multiplied those two whole numbers together, what would be my answer approximately? 12. Okay, so my answer is going to be approximately, my computer is really laggy right now, approximately 12. Ooh, that's bad. I'm having technical difficulties, you guys. What in the world is going on? All right, try that again. Or we won't. We're just going to say 12. 12. All right. Ah, it's not working. 12. Okay, so our answer is going to approximately be 12. Now, sometimes on a test or a quiz, it will ask you to solve this problem, and it will give you answer choices like this. 1 and 4,076 10,000ths. It will give you 14 and 76. Sorry, I did that wrong. 14 and 76 thousandths. It will give you 140 and 76 hundredths, and it might give you something like 1,407 and 6/10. So if those were your answers, what do you notice about those answer choices? Well, the decimal's in a different spot, but all of your answer choices have the same digits, 14076, 14076, so on and so forth. So what do you think, what do you think you're going to get when you multiply 2 and 3/10 times 6 and 12 hundredths as your answer? You're going to get a result of 14076 as your digits. But if you did a quick estimate, there's only one reasonable answer. If we said, oh, our answer is going to be about 12 whole, which answer is the only one that's going to be reasonable? Yeah, this guy right here. This is the only answer that is reasonable. Okay, the only difference in these four answer choices is where my decimal point is located. Okay, if you think about it, 1, 2, 3 places after my decimal point, 1, 2, 3 places after my decimal point. So a lot of the times a quick estimation can help you pick your answer, especially if you have answer choices that have all of the same digits, okay? I know that by looking at these answer choices that when I actually multiply those two numbers together, I'm going to get those numbers in that order. Okay, it's just a matter of where does the decimal point go. Okay, so let's think about, I'm going to give you another example where you just have to pick out where the decimal point is going to go in the answer. So I'm going to make this up as I go. So we're going to say 7 8/10 times 10 3/10. Okay, so 7 8/10 times 10 3/10. And my answer is going to be these numbers. What in the world is going on with my pen? Okay. Where is my decimal point going to go in that answer? Couple different ways we can think about this. We can say, like right here, right there. Okay, how do you know that? Mm-hmm. Okay, so let's say we did 7 times 10, all right, because those are my whole numbers, right? What is 7 times 10? 70. So my answer has to be approximately 70. If I put my decimal here, is that going to give me something close to 70? No, that would be more like 8, right? If I put my decimal point here, that's going to give me 80 3400. That's close to 70, correct? Yes. If I put my decimal point here, what is that going to give me? Yeah, that's going to be 803 4/10. That's way too big. So my decimal point must go right here. Okay, because that's going to be the closest to my estimated answer, which my estimated answer is approximately 70. I'm going to give up on, oh no, I'm going to give up on writing approximately. Going back here. I'm on the struggle bus today, guys. Okay, so you could think about it, what would I get if I estimated? Or you could figure out where your decimal goes by counting how many decimal places you have in your factors. So I've got 1 here, okay? I sometimes call them scoops. So I've got a scoop and I have a scoop. So I have 2 scoops. And so I know that when I get my answer, I have to move those scoops back to the left. So I have to go 1, 2, back to the left, and there's where my decimal point goes. Okay? So we will work on dividing decimals on Thursday. Okay? So Thursday is dividing decimals. Wednesday is multiplying decimals. So refer back to this video if you need a refresher. And that's all I have for you today. Catch you on the flip side.